Do a quick review on chapter 5 since we were unable to post that before we actually took chapter 5. If you're happy with where your score is, feel free to keep that. Otherwise, you are more than welcome to retake chapter 5 test. And due to the situation we found ourselves in, we're going to say you can retake it up to full value of whatever you get. So up to that 100%. So go ahead, take a look at this. If you feel like you want to retake your test and you're unhappy with where you were, please try to retake this in the next week or so. If you want it posted in your midterm grades, then definitely try to get this in before Friday this week, the 11th. All right. So number 1, stuff from chapter 5 here. We're going to take a look, and I'm going to actually go over the test that you guys already took so you can correct your mistakes. And then we'll have a similar test with different numbers that you can take as the retake. So is the following a one-to-one function? What you want to be able to do is basically just type this either into the calculator or build a table and create a sketch. And what you should see is this thing's going to look kind of like that. And in order to determine if something is a one-to-one function, we want to know, is it a function, which in this case it is, but is its inverse also a function? And in this case, if I were to find the inverse, one of the ways to look at it visually is, does it pass the horizontal line test, which in this particular case, it does not. So that's going to cut through. This is not a one-to-one function, so no. Find the inverse of a function. In general, the inverse is every xy is now a yx. So if we were to solve for it, we basically just flip-flop all of the x's and y's and then resolve for it. So in this particular case, we get x minus 6 square rooted. And then we'll add 3 at the very end there. So our new inverse of x is going to be the square root of x minus 6 plus 3. That'll become our inverse. Okay. Next thing we're going to take a look at is just solving stuff. These ones are the ones with the uniqueness property. So hopefully what we recognize is that 27 can be written as 3 to the 3rd. And then if you have same bases, you know that their exponents must be equal. So 2x minus 1 has to be equal to 3 since they both have a base of 3. So 2x will equal 4, or x will equal 2. Okay, another uniqueness one. This one's already set up. E is the base of both of these, so we can just go right ahead and say that 3x plus 4 equals negative 2. And then we'll work through this, see that 3x will equal negative 6, and x equals negative 2. Okay, so those are our 2 solutions on those uniqueness properties. The next type of thing we're going to take a look at is going to be looking at depreciation. The top formula, the y equals a times b to the x, is kind of what we're going to look at, where a is our initial value. So this is going to equal 150,000. Our depreciation, or the growth or decay factor, if I lose 18%, that means 82% will remain. So we can multiply this by 0.82 to the x, where x is our number of years. In this particular case for A, we want to know how much is it worth after 5 years. So we'll plug 5 in for x, and then this is just a number. Type that in the calculator, we see that the truck will be worth about $55,610.98. Okay. So that's what our truck should be worth after 5 years, assuming that it only loses 18% of its value each year. So then we want to know, when is it going to be worth less than 25,000? So now the value of the truck, that's our y, so 25,000 is going to be equal to 150,000 times our 0.82. Now the unknown is our time, which is our x value. So we can divide both sides by the 150,000. So we end up with 25 over 150, which actually can reduce more, down to 1 over 6, but this will equal 0.82 to the x. To undo an exponent that is a variable, we want to take the log or natural log. So we have the log of, again, this can reduce further down to 1/6. X times the log of 0.82. And this is that property that when I take the log of both sides, I can take the exponent and move it out front. And so then our final answer is the log of 1 over 6 divided by the log of 0.82. Okay, which this gives us approximately 9.03 years. Okay, most of us I saw were putting 10 years in there with no work shown. So it looked like you lost a lot of the points there. And so if you're looking in the table, you know, yeah, there's nothing between year 9 and year 10. That's when it's going to be worth less. So technically it's right, but just know exactly how to find this and solve it this direction, so that'll help get you the full credit. Or if you're showing it from a table, at least show that table of values so that you have a little bit of work behind it and you may be able to get those partial points. Next thing we're going to take a look at is just putting things in logarithmic and exponential form. So there's my base, so I'm going to use natural log of the 148,4045 is approximately 5. So this is just converting from our exponential into logarithmic. This one will go from logarithmic into exponential. So our base is 4 to the 3rd equals 64. Okay, so those ones are hopefully quick, easy, just conversion ones. These ones are, again, some of the tricks we learned with logs. So when I use subtraction, I can combine this as a single term using division. So this is 32 over 4, which would then simplify into just natural log of 8. Multiplication, we can split this apart as addition. And then again, we kind of talked about it, but let me kind of demonstrate it a little bit better this time. The first step, the multiplication, allows us to write it as 2 pieces with the addition, and then I'm allowed to move these exponents out in the front. So we end up with actually 4 log x plus, and the same thing here, I can move that 3 out front. So 3 log y, and then this is expanding it with simple logarithmic terms. Okay, so those are hopefully a bunch of the simple kind of tricks and just working through pieces. Now we'll work on to the back side. Again, look at solving. You want to get your variable isolated, so we need to subtract this 3 first. So this will end up being 8. We'll divide by 4 to get the log completely by itself. So log . Okay, now I'm in logarithmic form. Let's undo this using exponential form. The base of log is 10, so I know that 5x is going to equal 10 to the 2nd power, which is 100. Okay. And so if I divide both sides by 5 now, we see that x is going to equal 20. Okay, so we're going to use that exponential form to help us undo. Here, let's divide by 2 first. So e to the 3x minus 1 equals 4. We'll add the 1. Now, again, to get that exponent out, let's use logarithms. In this case, I want to use a natural log. So this becomes 3x. Natural log of e, just kind of remember that the natural log of e, that is 1, so that kind of just disappears. And then this equals the natural log of 5. So that's what happens is we take the natural log of both sides here. and then we'll divide by 3. So x is going to equal natural log of 5 all over 3, which is approximately 0.5365. Okay, now we'll get into some of the fun story problem stuff, some of the actual applications. College savings, Grandma Grandpa throw $10,000 into an account for you. Thanks, Grandma Gramps. We want to see how long or what this thing's going to grow into. So our simple interest is going to be the amount that we start with, or the principal payment, which in this case is $10,000. And then we're going to let it grow with compound interest, 1 plus. This is going to be 6.8%, which is a decimal, is 0.068. Compounding monthly, we're going to let it sit in there for 18 years. And again, it's compounding monthly, so 18 times 12 will give us the number of months, so we have the number of compounds. This is just a number. Throw that in the calculator. We see that Grandma Grandpa's investment actually turns into $33,890.34. So that's super nice. And again, thanks, Grandma Gramps. Then let's take a look at continuous compounding. Okay, ideally, the more things compound, the better. So continuous compound would be awesome. We're going to have the amount here is the PERT one, so the principal investment times E to the RT, where the interest rate is 4.7% this time. And we're only going to let it sit there for 2 years. How much will we have? Again, this is just a number, because E is a number. So just type that in the calculator. Should tell us that we'll have about $1,647.84. Okay. So we say for 2 years there, continuous compound, that's what we should get. Last one, our $1 million question. There's the really long, complicated formula, where if we use A equals, and then it's that principal payment with 1 plus the interest rate and the Tn minus 1 all over R. It's that really, really ugly, complicated one. You can do that, and it will work, but it's really ugly. The other thing I would recommend you doing is using the calculator and its financial app. So actually it's probably going to be loading here shortly. But what we're looking for is our number of payments is going to be that, in this particular case, we're going to invest for 47 years, compounded monthly, so we end up with 12 months for 12 compounds because it's monthly. My interest rate as a percent is going to be the 8.9%, but it's compounded monthly, so we want to divide it by 12. Our present value is given to us as 0. Our payment, again, negatives for this is going to show direction of cash flow. So I'm going to type this in as a negative 100 because I'm giving the bank $100. And then my future value is going to come out as a positive value, and that's what the bank will give me back. So let's see if we can get this in the window so you can see. So if we're in here, again, you want to go apps, finance, and then the TVM solver. So our number of payments here is going to be the 47 years times monthly compounds. It'll do the math for us, 564 months. Our interest rate is 8.9%. Since it's as percent, we'll leave it as a percent. But we want to divide it by 12 because it's compounding monthly. That gives me that periodic interest rate. My present value is 0 because I'm going to start with no money in there. My payment, again, we're putting $100 a month into this thing. And we want to figure out how much money we have. So solve is the alpha enter. Looks like we have $856,000. So we have figured out that if we're saving $100 a month at age 60, we'll have $856,000, $962, roughly. Okay. Similar idea. I'm not quite a millionaire, which is what I wanted, so let's figure out when will I become a millionaire. Okay, or you can do all sorts of stuff. We could have also asked, well, how much money do we need to save in order to be a millionaire? So again, you can do the exact same equation here, but now you need to solve for your number of payments, which that becomes a mess. Or let's use this same TVM solver. Now this time, my n is the unknown. This stays the same. Present value stays the same. My payment stays the same. But now my future value, I want that thing to be a million. Okay, so that's what we're going to go type in. There's all my zeros. Okay, so this is going to be a million. So when we go to change this, let's make that into a million. So again, that's the money I'm getting from the bank, so we're going to leave that as a positive. 6 zeros. Negative number because I'm paying the bank that. My number of payments then is going to be 584. Remember, this is months, so I want to figure this out as years. So I can go ahead and divide it by 12, and it will tell me it takes 48.7 years roughly. So we're going to see that this turns into about 48.7 years. So if we assume that you were age 18 when we started this, 47 years plus 18 gives us that age 65. And so you can either put down the 48.7 here. I would take that as an acceptable answer because you did the math right. But technically it says, what age do I become a millionaire? So plus 18 to this tells us that before our 67th birthday, we should crack the $1 million mark. Just saving $100 a month. So that's nice. And just kind of finish up for fun for you. The other way we could have done this is, what if you wanted to be a millionaire at age 60 still? So 47 years of saving, but you want to change your payment. We can figure out how much you need to save. So the only adjustment is, if you wanted that $1 million by age 60, bump up your little monthly contribution by $17 basically. Okay, $116.70 will give you enough money per month. Will grow over time to make you a millionaire. Okay, so that's kind of a quick summary of the test. Hopefully that helps you. If you got any more questions, let me know. And good luck. Good to be back. See you guys in class.